In this video, we will learn quite an important concept called a mass flow rate. Mass flow rate is, let's use MSR, this abbreviation. Mass flow rate definition is mass over time. In other words, how much mass pass per time. So knowing that, we know our US unit will be how many pound mass pass per second, right? And for SI unit will be how much kilogram pass per second. So mass flow rate actually have another symbol is m dot. Dot in engineering in use means divided by time, right? You learned in your calculus, for example, y prime. Y prime is with respect to distance, dy over dx. X is distance. And however, if you have a y dot, that means dy over dt. That's derivative with respect to time. So here, mass flow rate is going to be m dot because it's divided by time. Okay, so knowing that mass flow rate is mass over time and having unit of kilogram per second, how is mass flow rate related to volume flow rate? And there was an earlier video talking about volume flow rate. If you needed to review, click on that one. So this means volume flow rate. Do a quick recap on volume flow rate. Volume flow rate is volume over time, and therefore the unit for our SI unit will be in how much meter cube pass per second. Okay, so here we're saying mass flow rate is related to volume flow rate. So let's see, mass flow rate is volume flow rate times this something unknown. And how do we figure out what this unknown is? We're going to use our dimension homogeneity to help us figure it out. Dimension homogeneity, you know that it's something about the left-hand equation and right-hand equation. They're going to have the same dimension, right? If it's about mass, they have to be all mass. If they are time, they have to be all time dimension. We cannot say mass is equal to time, right? We cannot say 5 kilograms is equal to 5 seconds, right? That would not be dimension homogeneous. So here, we actually use dimension homogeneity quite often in engineering problem. So here is an example for this. Mass flow rate, we already know that's kilogram per second. And volume flow rate right here is meter cube per second. And so what will be this unknown? This unknown will be something that times we get rid of meter cube, then we will desire this kilogram, so we'll have this. Then the question is, what is exactly kilogram per meter cube? That is mass per kilogram. Mass over volume. What is mass over volume? That is our density rho. So now you find the missing link here. And here we can write down the whole equation. Mass flow rate is equal to volume flow rate times density. That's it. That's how mass flow rate is related to volume flow rate. And the missing link is our density. Okay. And one more concept to go over. Quick recap of volume flow rate last time. Volume flow rate, not only just volume over time, it's also equal to velocity times cross-section area, right? That's one of the concepts we're talking about in volume flow rate in the previous video. So look into that. And that's velocity times area. So in that case, if we substitute that into this new mass flow rate equation, it's going to be equal to velocity times cross-section area, then times density. because velocity times area, that's our volume flow rate. Volume flow rate times our density, that's our mass flow rate. So knowing that, this is going to be our new equation, okay? I'm actually going to erase this. It's confusing. Okay. So that's mass flow rate equal to velocity times area times density. Okay. So that's the concept about mass flow rate. Okay. I'll see you in the next video. Bye.